Giving it our best effort. So a couple of things I want to look at really quickly. How many of you are members of PBL right now? How many should be in this class members of PBL? Okay, so I'm going to give you a little plug. I don't think any of the officers from PBL in here that are going to give the plug for me. What, you're not an officer of that one? One group. All right, so PBL is really a business organization. It's got a lot of great features. It's a great networking opportunity. And we are working, so I spoke recently with our sponsor, Dr. Grocery and Ryan, about can we do online members? And the reality is we can. There's actually a state chapter for online members. But we will certainly work with people locally. It does cost a few dollars, but in a lot of cases, those dollars get returned to you when you go to state and local contests. We have had students that have done very, very well at both state and local events. This year, the national conference, if you make it past the state championship, is it in Atlanta, though? I think so. Atlanta's a great city to go down and visit. So if you have any interest at all, and I would encourage you to check into it, you can contact me and I will direct you to the appropriate people. You can contact Dr. Grocery and Ryan if you're in one of her classes. You can grab one of the members and they will all lead you into that. Second thing I wanted to talk about was that CAP-In. Remember I'd offered the ability to pass the class with an A if you take the CAP-In. Well, we ran into one tiny little hitch. I have a student, at least one, that is actually applied to take the CAP-In. Got through PMI because you have to first apply through PMI. And PMI said, yep, you have enough credits, you can do it. The test used to be administered at essentially every Prometrics exam center. So Lincoln, Omaha, for whatever reason, it is now only offered. The closest areas are Kansas City and Sioux City. For whatever reason, Omaha is no longer a certified center. So this student's been poking, and I've been kind of working my way up through the Omaha and Lincoln chapters, trying to get them to figure out what the issue is. Because there are certainly a lot of PMI members in the area, and why Prometrics. So it's a computer-based exam. I'm not quite sure what the logistics are, why Prometrics isn't allowing you in all their testing there. So just a quick update on that. As soon as I find out anything, we'll let you know. And then I said, well, there's these local chapters in both Lincoln and Omaha. And both chapters have a lot of things where they called like a lunch and learn or a dinner and learn, where if you've got your PMP certificate, you have to earn so many credits. So part of that is it's a very educational. So there'll be an hour worth of lecture or learning or some kind of activity, and then a dinner. And I thought, well, great. We'll see about taking you guys out one of those and meet you up in Lincoln or Omaha. Sometimes they're held, a lot of times at like Granite City breweries, some really nice places. And everything so far has been scheduled on Tuesday nights. Is there a problem with Tuesday nights? I haven't. So one day I had the night club. So I've been working with them trying to come up with some alternatives. And I know during the lunchtime it's actually a little hard for a lot of us to get away. We have classes. And we would hate to miss other classes, wouldn't we? We would hate to miss classes. All right, so we're working on that and trying to see if we can't find an interesting time to go up there. So, had an interesting customer service, not directly project management, but it is related to that idea of risk that we're going to really address on Wednesday. So, one of the things that's changed in the world of hospitality is social media. And so, restaurants and other venues have to be very conscious of social media. And so one of the things that happens is it's very hard to get positive publicity, but it's very easy to get negative publicity. So if I show up at a restaurant and get a bad meal and I start posting on Facebook and other places that meal was horrible, very quickly that's kind of a viral anti-marketing campaign if you really want to think about it. So we went to Kansas City this weekend. We went to eat at a restaurant called the Melting Pot. And if you haven't ever been to some place like this, it's a really interesting place. It's fun. You kind of have a group meal, and it's cooked at the table. But it's a little pricey. It's about 50 to 60 bucks a person by the time you go in there. More if you do indulge on the wine bar, which I did not. So we get in there and we get seated by what turns out to be the manager of the restaurant. We had reservations, and it's in the plaza in Kansas City if you've been in there. Really kind of a little swanky area, but it's kind of fun to go to. We waited about 10 minutes. No water, looking at the menu, nothing. No waiter came by, no waitress. Nobody even looked at us. Really weird. Well, the manager came by and said, "Oh, you guys have been sitting here for a little while." Yeah, not too, we didn't, we weren't complaining yet. He says, "Well, I'll tell you what, it's meals on us. We're waiting 10 minutes." So we ordered and we ate. Meal ticket was $119. Now, the waiter that they sent over did an excellent job. I put a lot of positive. I went onto Yelp and added a positive review. So I'm hoping that that $119 is a positive experience and that they made a learning effort or a curve. So that risk, because he doesn't know who I am, that I could come into this class and you guys are all going out for $50 meals every day, right? Yeah, I don't either. Trust me, I'm looking at the menu going, how much for what? But I got a really positive experience out of it. And so the reality is, did it cost them a whole lot? No. Did that waiter make a heck of a tip on a free meal for 120 bucks? I think we tipped him 50 or 60 bucks. So he made a pretty good. Now, and it's an interesting dining experience because the other thing, it was a non-rushed experience. And most restaurants you go into, and they kind of rush you, would like you to get in and out of there because then they can seat another table. We were there from 6:30 till 9:30 eating supper because it's a slow, interesting process. But if you go there, it is the most amazing food I have literally had ever, including the dessert. I left there feeling like somebody should just shoot me, but it was an interesting experience because it's the final dessert, and there's a ton of different chocolates and things you can get. But they actually have melted chocolate in a pot in front of you, kind of like a fondue, and bring you things to dip it in. So you're dipping like chocolate brownies in melted chocolate. It was interesting. But the point about that is that risk analysis. How do I save face? And it's changing for restaurants. And we're going to look at other industries it's changing for. So even in education, there's that one person posting about their bad financial aid experience at Peru, for example. And I say financial aid because that's the one that as an advisor I see the most student frustrations about. Does that affect other students when they see those posts? It certainly does. And are there items, yes, financial aid might be able to do better, but are there things that they have no choice over it? And that's also true. So, quick announcements. Anything else anybody needs to mention other than my blowhard stuff? All right. So, very quickly, we're going to do it. The beta analysis. You will need to know how to do a beta analysis. It's the easiest measure we are going to look at the entire year. If you turn your PMBOK guide to page 337, there is actually a chart. And there's another distribution called the triangle distribution, which is really what we end up doing, but it's very close to the beta distribution, and so we can call it a good idea. So the thing to remember, though, is it's pretty simple. The low plus 4 times the most likely plus the high, or the optimistic plus most likely plus pessimistic. However you want to think about those, you have those 3 values on top, 1 multiplied times 4, that most likely, all divided by 6. Easiest math problem we will do all year. The key, though, is where do I get those estimates from? Where might I get those estimates from? So if I've done this project in the past, do I have those values I can look at? So the worst case, best case. Maybe I have expert judgment, so I have other people who've done this work before. But this method only gives us a really good value if we have some pretty good ideas behind it. We have another measure that we want to work with. we want to look at something called expected value. And so if you turn your PMBOK guide to 339, they start talking about expected monetary value. We can expand it to other things for expected value. So everybody in here is over 21, right? So you can all go to the casino. Does anybody go to the casino? Does anybody? There's no winning strategy. The house always wins. But we can actually look at this and the same type of things, your expected values that you're going to get out of going to that casino. And so expected value has some interesting pieces. So for your viewing pleasure, we're going to skip pieces of this. We're really not going to watch 21 minutes of it, but it is available in length in this video. Ignore the fact that it says Statistics 101. You don't need to remember statistics. Statistics, scary term.
Now, a few points before we get going. Number one, even though this first slide says statistics, the concepts in this video are also applicable to finite mathematics. So you may be watching this video in a stats playlist or a finite math playlist, but either way, the concepts apply to both. Number two, these videos are geared towards individuals who are relatively new to stats or new to finite mathematics. So I will just be going over the basics, lots of concrete examples. Number three, if you like the video, please give it a thumbs up at the end. Or if you have suggestions on how I can make them better, please leave constructive comments below the video. All right, all that being said, let's go ahead and dive right in. Now, in this video, we're going to talk about the basic concept of expected value. Now, let me tell you, having worked dozens and dozens and dozens of students in finite mathematics, this is one of those concepts that is actually relatively simple, but for some reason is hard to grasp. So I'm going to go through the very basics of expected value and work several examples so you can see exactly how it works in different types of problems. So that being said, let's go ahead and dive right in. So as always, we're going to start with an introductory problem. So on your Psychology 101 syllabus, it states that your final grade will be determined in the following manner. And of course, if you've been in college courses or maybe even high school courses, it doesn't matter, you've seen something that looks like this. So you have four major types of assignments: homework, quizzes, a midterm, and a final exam. Now, of course, those do not all count equally towards your final grade. They are weighted differently in determining your final grade. So in this case, our homework is 30% of our final grade. So we give it a weight of 30% or 0.3 in probability terms. Quizzes are worth 20%, so 0.2. The midterm is 25%, so it's worth a quarter of your entire grade, so 0.25. And the final exam is also worth 25%, or 0.25. Now, if you notice, the weights in the weight column, some are add up to 1. And that should make intuitive sense. They have to. If they only added up to 97, you could get 100 on all your assignments, but only get a 97 in the course, which makes no sense. So,
okay, so key one, expected value, all the weights that you are going to use, or probabilities, we're going to call them also here fairly quickly, those have to equal 1. So, taking you back to stats, anybody having flashbacks yet? Hunter, you're okay still? Okay. We haven't done the network diagram yet, so you're okay.
should, be fairly straightforward, but the probabilities or the weights have to add up to 1. So you receive the following grades. Your homework grade was an 89%. Your quiz grade was a 79%. The midterm was an 84. And the final, you really came through at a 92. So those were your actual grades on those 4 major parts of the course. So at the end of the semester, you left this information. Your homework grade was an 89. Its weight in your overall grade was a 0.3 or 30%. 79% with a weight of 0.2. Midterm, 84% with a weight of 0.25. And of course, your final, which you did really well on, was a 92% with a weight of 0.25. Of course, the question is, what is your final grade in the class? How do you go about calculating? Now, I'm sure many of you are, done this before. You're all very smart people, so you should know how this works. So all you do is take the grade you got in each component in the course, multiply it by its weight, and then add all those together. So 89% times 0.3 is 26.7%. That's kind of like a sub-score. That's the proportion of your total grade that is represented. So quizzes were 79% times 0.2, of course, that's 15.8%, and so on and so forth. So when you add up all those little sub-scores there at the end, which is the grade times the weight, you end up with a final grade of 86.5%. Of course, which is rounded up, or I would round up to 87%. Now, congratulations. You just did everything you need to do conceptually and in terms of calculation to find an expected value. And actually, in a way, you actually figured one out. So not only did you do that, you also earned nice, solid B in the place. So what exactly is expected value? Now, the expected value is simply the mean, or the average, I'm going to use mean, of a random variable.
So I want to do an example. And we call it expected monetary value because we're interested in what? Money? We are. So we're going to go to this sheet. So please open Excel. And we're going to play modified roulette. How many numbers are on a roulette wheel? Ooh, a lot. Does anybody know right offhand? So what numbers are on a roulette wheel? Well, we can Google it and find out. But the key to roulette is, what numbers does the house win on that you can never win on? What numbers does the house win you don't ever win on? There's two numbers you cannot pick on the roulette wheel. Oh, you guys have roulette players. So you can't bet on the 0 or the double 0, right? Because the house has that edge. So we're going to do something similar. We're going to put in a couple of numbers, and these are going to be our results. So we're going to make it a little simpler. So we're going to have a wheel, and that wheel is going to have a 0, 1, 2, 3. We don't want to make this too complicated because, well, I don't want to make it too complicated. So your wheel can stop at any of those 4 spots. So what's the chance that I can stop at any one of those? What's the probability that I'm going to stop at any of those? 25%, or just to make life easier, we all know that 25% is the same as 0.25, right? Good. So I'm going to put in here 0.25 in all of those. Because that is my probability that it's going to end up on one of those. Well, we have an interesting way to bet. So in this particular case, we have a little modified roulette wheel. And so we know if it rolls on 0, what are we going to get for $1 back? Are we going to get anything? So we put $1 in and we're going to get how much? 0 back? Okay, that seems fair. So on the other hand, if the wheel spins on a 1, we're going to get $1 back. If it spins on a 2, we're going to get $2 back. And if it spins on a 3, we get $3 back. So We're going to call this the winnings. So that seems like a pretty good game, doesn't it? You put $1 down, and then depending on how that wheel turns, you could get anywhere from $0 to $3 back. But we want to see from the casino side, is this a good deal? And from your side, is that a good deal? And so we need to do something called expected value. And so what we're really doing is we're adding up the probabilities of all of these individual pieces. So we know that a quarter of the time, or 25% of the time, you get 0. Well, that was pretty easy to calculate. What's 25% of 0, or times 0? 0. But on the other hand, so we can make it an easy formula, so we could just say equals that probability times my winning. And so I could then scale those down very easily, couldn't I? So now I have those individual probabilities of what happens to $1. So my expected value then, I'm just going to take the sum of those. And so if I sum that column, I have now got an expected value. I click up here, I click with sum. Oh. Well, this looks like it's really a good deal. Because what my expected value is, for every $1 I put in, I expect to get out on average $1.50. Huh. So this person setting up this roulette wheel or this gambling scheme, this is a really nice gambling scheme for me as a player, but is this going to be good for the casino? No. And in fact, what you're going to find out when you start looking at some of these numbers, if you look at, you go by a casino and it says 97% payback on slots, what they're really telling you is that expected payback. So let's modify this a little bit. And the great thing about Excel is once I've created this, I can start modifying. So if I'm a casino, what might I modify first? What could I modify that seems to have the biggest impact on that? So what if I said, you know, I don't care where it lands unless except it lands on a 0, I'm going to give you back $1. So I change those to $1 and $1. So now my expected payback is 75 cents. Is that a little more likely than what you're going to have in a casino? So on average, I put $1 in, I get $1 back. Now, there's some other things we could do with this, but this is a really quick way of that idea of an expected value. What's going to happen? And so casinos are a good one. And there's a problem in here. There's a case I gave you for. Maybe I didn't grab that one. In the class, there's actually one where it goes through and does a wheel and does something very similar. But this is a very simplified, quick example. We're looking at expected value. So we look at those probabilities, and they don't have to be 25, 25, 25, 25. So if I think about that wheel as being maybe it's lumpy, maybe it stops on something more often, those probabilities could change. And so maybe if it's not a wheel, but it's a deck of cards, what's the percentage of time I'm going to get a pair versus a full house or a suit? So they're certainly different, and we look at those probabilities. The one thing that we do have to know is, what do these probabilities have to add up to? They have to add up to 1 or 100%. So we cover all of our bases in there. So, similar type of an example. Now we're going to change this to our business. And so our business has some things we want to talk about. And we look at something called decision tree analysis. You guys have done this, you just haven't really put the numbers to it. Because in a lot of cases, we have multiple choices or multiple things that we can do. And so if we can do expected values here, we can also do them with something called decision tree analysis. And so, because he's got a cool soundtrack.
Okay, guys, today we're going to talk about the decision tree analysis. We're going to start with a story. Our example is you can choose to own a bike shop and make roughly $400 a day, or you can choose to own a clothing store and make roughly $600 a day. Which one would you want to choose? The obvious answer would be the clothing store because you make more money. All right. However, there is a catch. Bike shop has a 50% chance of success, as well as a 50% chance of fail. As does the clothing store, with a 50% chance of success and a 50% chance of failure. However, with the bike shop, with a 50% chance of success, you could make $400, as we discussed. If you fail, you have the potential to lose $150. With the clothing store, if you succeed, you have a 50% chance of success of making $600. If you fail, you could lose $200. So now which one can you choose? Alright. The formula at the bottom is you take a 50% chance of success times the possible $400 you can make with that success, plus the 50% chance of failure, and then $150 that you could lose. That gives you $125. That's for the bike shop. We'll do the same thing for the clothing store. 50% chance of success, times $600, 50% chance of failure, and you're going to lose $200. So that value is $200. So for the bike shop, our value is $125, and for the clothing store, our value is $200. These two values are going to be expected values of the project or of the business. Since this is a business and we're talking about business, we're going to take the bigger value.
Okay, does that make sense? We're comparing two options, and those options we're comparing give us an expected value. So we can put in the details we know. So think about, we're going to open that bike shop. Now these are just rough numbers, but you assume that bike shop in a year would make you $400. On the other hand, if you failed and went bankrupt, you spent $150 or whatever to launch that. And so those are your expected values. These are just a couple of really quick examples on how we can do that. We can do the same thing with our Excel sheet. So we're going to open up a business. What kind of business do we want to open up? What kind of business do you want to open up when you graduate? Anybody want to open a business? Grow out a business. A coffee house, great. So we're opening up a coffee house, we think. And so these aren't winnings, but this is going to be our expected, what we think we're going to make if that coffee house succeeds. So if that coffee house succeeds, we're going to make $10,000. So I could put in 10,000. So succeed. So we make $10,000. Well, what percentage of new businesses succeed in their first year? Just a rough number, do you think? Do you think half? Do we think 20%? Do we think 50%? So let's put 20% in there, so 0.2. So the other reality is a lot of businesses that first year, they struggle and they manage to break even. In other words, they didn't lose any money, but they didn't make any money. And so I'm going to say that's maybe a bigger percentage. So maybe 0.4%. So they're gonna break even. And then we have a complete failure. The business tanks, they go into bankruptcy. And so I'm going to get rid of this bottom line just to make life easier. So right now, there's a problem with this, isn't there? I say 0.2% are going to succeed, 0.4% are going to break even. What does the failure percentage have to be, or the probability of failure? What does that have to be? Point 0.4. Those have to add up. And if I fail, maybe that business was very expensive, and I put a negative number in. And if those are my percentages, and that's what I really think is going to happen, does this look like a good business that I should invest in? Because my expected value on average then is a negative $7,000. So it's another tool. I can make comparisons of business choices. So maybe I have another business I think I could get into. And so to cheat, I'm just going to copy this. So it's got all the formulas. I go Control C, Control V. And so rather than a coffee house, what other business might I start? What seems to make a lot of money? A gym. Okay. So we're going to create a gym. Eric's going to train us. And maybe our chance of succeeding in a gym we think is really 0.3, break even. Maybe we don't even think there's an option for a break even. Maybe we really think it's 0.6. If our gym succeeds, we're going to make $5,000. And if we fail, so we can even just take this out as a percentage, because we're either going to succeed or fail. There's no break even in this. So our failure is 0.4, and if we fail because we're leasing the building, we're only going to lose $6,000. And now we have two alternatives. So we have a coffee house and we have a gym with those expected outcomes. Which one seems to be the best use of our resources? By those numbers, it would be that gymnasium. And we can use those expected values to make a lot of decisions when we start looking at risk. We want to look at what is the percentage that we think that a tornado is going to hit versus the percentage we think a lightning strike is going to hit in Peru, for example. And we can start using those a lot. So expected values aren't that hard, are they? It's really just a weighted average. So don't let the term in the book statistics or that expected monetary. And we can do them where they're even far more complicated if you wanted to. But notice Excel does all the heavy lifting for us. I don't have to calculate those. And I can look at what my expected value is. So in this particular case, my expected value would be $600 to open a gym. Now hopefully I've paid myself a salary and it's not $600 for the entire year, or even ramen noodles are going to be too expensive. But we can look at those alternatives. So we can look at anything that has multiple options, we can assign this to. Now, where do we get numbers like a coffee house succeeds, fails, or breaks even? Are there sources of information we can find for that? Are there trade journals we can find? Is there U.S. government data? Yeah. So like some of that Census Bureau data, Bureau of Land Management, all these different groups have tons of data, and we can look at what's happened. We can look at local areas. So one of the things that happened, and coffee houses are a great idea, but one of the problems is, in a bigger city, is there a Starbucks on every corner? What I am waiting for is to see a mini Starbucks kiosk inside the big city. I mean, because they are literally, in some places you go, they're on every corner. And at at some point, I think it's unsustainable. But I see other ones that seem to be succeeding. Caribou Coffee and other specialty ones seem to be succeeding. I see a lot of gyms. How many gyms are there even just in Nebraska City? And it's not that big a town, and there's several. If I go to Lincoln, are there gyms on every street corner, it seems like? No. So we can look at those expected values. If I buy a piece of equipment inside my gym, I can look at that expected lifetime of that article. And so I don't have to use it just for that. All it really is a moving weighted average. And so your in-class assignment for today so what is your expected return on your investment? If you invested $100 and had the following items. So, oops, should be of. A 0.25% probability of a return of 125%. A 0.35% probability of a return of 85%. A 0.10% probability of 145%. Or a 30% probability of 90%. Do we have enough information there to work a problem like this? Okay. So that is your attendance for today. That should take you about 3 minutes to set that up in Excel. Maybe a little longer. So the first thing I would do whenever I do those is make sure those probabilities add up. And if they don't, then we have a problem in our setup. Okay. So what happens if you sum these? It's a sum of all of these. Ah. Does it look logical? I haven't actually run the numbers, but Does that seem to make sense from the numbers you have? It looks logical. Let's see what everybody else got. And if you remember, you have to sum all those expected values. And if you guys are all on the right track. Okay, everybody get this problem or a number? Who isn't done yet? So we invested $100. Remember, we're looking for dollars, not a percentage. So you should be getting a value in dollars, not in percentages. Now, you use those percentages to calculate, so you should have, move it over here a little bit so I can see. So you're going to have 0.25 in a column, 0.35, 0.1, 0.3, but you're multiplying those weirdly times percentages. Now, this end result, so if I just multiply that percentages, I end up with, I'm going to be at 1.025%. Well, I also gave you a number of how much you put in there. So you put in $100, what would be my expected outcome then? It would be this percentage times $100, which should be, what, $102? So maybe that's a good investment. So we can make it a little trickier by putting in pieces like that. All right. So the video we watched last Wednesday with the guy who couldn't figure out how many days were in a weekend, by Thursday, for whatever reason, and I don't think it had anything to do with our class, that entire series of videos from Microsoft got sent to private and unviewable. Great. Interesting. So there's an alternative video in there, and there's a ton of help stuff in Microsoft Project. So we're going to actually open up Microsoft Project, and we're going to create our first little Microsoft project. Now you'll notice there's a homework assignment, and so I think we now have all the pieces to do your homework assignment, except for creating this project. And so I'm going to create with a blank project. So it looks a lot like if you're used to Excel or Access, and it says, well, what are all these items? So we're going to start out with something we do every day. So what's a task everybody does every day? Brush your teeth. Well, that might be a task in there. But what we want to do is schedule out something that we do every day. And so the first thing I think of is we're going to attend class. So we're just going to, I know this is a really weird thing, but we're going to go and we're going to schedule out attending class. So the first thing we need to do is think about what is the first thing we do. We're going to start out the first task in the morning. What do we have to do? So we're going to put in a task called get up. So we're just doing this very simplistic. We're just trying to make sure you get used to. So get up. And one of the weird things about a project is we're really looking at times. And we can set them by hours, we can set them by a specific time. But does anybody in here jump out of bed and instantly they're awake and ready for the day? Does anybody hit snooze 5 or 6 times before they manage to crawl out of bed? So we're going to assign we're going to say that this will take us 30 minutes. So if I say 30 minutes, an alternative way is 0.5 hours. And it's really interesting because Project is pretty smart. It understands 0.5 hours if I type it. So we know we have a task called get up. And so the next test, well, we know we have to do our hair. And my hair takes a long time to do. So I'm going to put in 1 hour to do my hair. We know we have to brush our teeth. So another 30 minutes for that. And so Excel can take all these task time. And because we know the construction out here is a little interesting to drive, we have to drive to Peru. Drive, park. And driving and parking in Peru right now is a little challenge, so we're going to give you 2 days to do it. I know, it's fictitious. I'm just putting a task time. So the other piece we need to think about then is, can we do all these things at the same time? Because right now the way we're doing it is we think they all start at exactly the same time and they're moving concurrently. But we know that's not true, is it? So we know that we have to start things, in some cases, with that idea of something called a precedence. So what I need to do here is I'm going to say, first of all, I'm going to put these into, I'm going to change this so it's auto-scheduled. And notice when I do that, it starts my start date here. And I can move that scale over a little bit so we can see some more information. And I'm going to set all these to auto schedule. There's easier ways to do it, but we can click each one if you really want to. So we know that one of the examples in the other book, or the other video, showed we could do that linking between them. And I'm going to show you the shortcut method, because I know how many days are in a weekend. See that number off on the left? That number is very similar to when we did our manual work breakdown structure, and that number is unique. Every item in here has a unique number. And so I can use that unique number to create a predecessor. Okay, Hunter, this is where you do start to have that heart attack of, oh my God, it's like what I've seen before. So before I can drive and park at Peru, I have to brush my teeth, right? We all agree on that? And so the predecessor for activity number 4 is activity number 3. And so if I just come over here in the predecessor column and I type 3, notice what it does on my little timeline. So it says, oh, those two are linked together, so I didn't have to go through the link, but I certainly can. And it says they're linked together, and what it's telling me is I have to do one task before the other task. Well, that makes some sense, doesn't it? Okay. Now, any of you very multi-talented at doing 2 things at once? Can you brush your teeth and comb your hair at the same time? So if that's the case, maybe I really have 2 predecessors, and Project can do that. So I'm going to go back up, and I'm going to put 2, 3. And when I do that, notice what it does. It links both of those activities together and says, hey, both of those activities have to be done before I can drive. I hope. Although I have frighteningly seen in the last week people brushing their hair, and that didn't freak me out as much as I passed somebody the other day when I went to Omaha, and she was doing eye makeup, steering with a knee, and both hands doing eye makeup, looking in the little flip down mirror, all the while driving 60 miles an hour. Right? But so hopefully we can do those before. So the predecessors then, I can also link them the other way. And so I can say, well, for both do hair, and brush teeth, I have a predecessor of 1. And so notice what it does here. It links all those activities together. So this is just getting us very familiar. This doesn't seem that hard, does it? This project, he seems pretty simple right now. So we can start to see when we have start and finish and all these kinds of dates. So let's go in and let's erase all these. Shall we erase them all? Easy to do. Can I highlight and erase? I can do all kinds of things with this, but let's get a little more realistic project. So now we're all used to putting them in. I just highlighted and I hit delete. So we want to think about tasks that are involved out here in this highway, curb, road project. And we want to break them down into that work breakdown structure. So things that we can kind of get a grasp on how long they're going to take. So, 1, 2, 3. All right. So let's break into groups of 3 people. Paying forward. Everybody except Kyle. Kyle has to get in a group of 2. It doesn't work out either way. All right. So I want you guys, you 3, to huddle, and on your project, I want you to come up with 10 paths out here on the highway construction project. And I want you to think about their task, how long it might take, and what their predecessors are. So we're going to go look at those. All right, same way with, let's take you 3. Ben, I'm going to move you just. I'm going to put you over here because actually I think it does work out with 3. All right, so if you 3 would like to get together, and then you 3 will scrunch together. And so on one copy of Microsoft Project, you're going to put in 10 tasks on a work breakdown. And it may be quicker, honestly, to have a sheet of paper and scribble some down. But I'm going to show you some other tools in Project where if we get them out of order, we can rearrange them pretty easily. So what I want you to do is get 10 tasks that we would do something out here on this road construction project. And then we're going to put them all up on the big one together. So we're going to combine them and take a look at some of those tasks. And then see how we can move them around.
Wait, do you want us to do like the big stuff or like?
I want work breakdown structures, things that you can quantify a work unit. So how can I break that down? And part of this is I want to show you the difference of why we do those work breakdowns typically on paper before we start shoving them in here, because you need to be able to break them down into small enough units that you can assign tasks and resources. So think about, how would I assign a task or a resource to an individual person or a small group of people? Because that's what we need to break them down into small enough pieces. So that makes it a little harder because we can't just sit down and do them on the fly. It takes a little bit of thought to do this.
I'm starting from scratch. Like,
You can start anywhere on that project, just 10 tasks. My guess is a project like this, you're going to have 1,000 tasks, so you can grab any 10. So I would think about maybe a subunit of that project, because we're not breaking down the entire project, but you may want to think about some subunit of that project, because you want to break it down into individual work tasks. So this tool is powerful, and we can assign resources, but only if we can break it down into small enough pieces.